Okay, so today we're gonna start with the Foraminifera and why they are important in micropaleontology. We'll discuss about the range of habitat of this of microorganisms and other certain terminologies that are quite common to this. We'll discuss in this lecture. So, in first part, I'll cover the introduction. Foraminifera. Why is it important in micropaleontology? These fossils are very remarkable for their stratigraphic importance. These are good indicators of paleo environments. Their range of habitat is mainly from deep marine to marginal marine environments. In the current situation, means the specimens that can be found in the present world, and also in if you see about fossils, they are found in rock records of such similar type of paleo environments in rocks of Cambrian age or younger age. What is foraminiferal ooze? It is a kind of lithological unit. So, what kind of a lithological unit? So, when some of the species of foraminifera are talked about, they are so numerous in number and they settle down on the seabed in and accumulate there in very large numbers. They form a kind of litho unit called the ooze. More specifically, the foraminiferal ooze. Now, what are oozes beyond continental slope primarily comprised of? Now, if you see, the ocean is divided into certain parts. It's divided into the continental shelf, the continental slope, the rise, and the abyssal plain. And the oozes in this part are mainly benthic, are comprised of benthic foraminiferas, and the oozes that are formed beyond the continental slope are being comprised of the planktic foraminiferas. Now, the benthic foraminiferas and the plantic foraminiferas therefore indicate two different kind of paleo environments, like we were telling or saying here. They are good indicators of paleo environments. So it's how. Now, two very good examples. If you're a patron of geology, then you should know about these two limestones. And if you surely read somewhere or elsewhere in sedimentary geology about these two kind of limestones, fusulonate limestone and nummulitic limestones. So these two limestones are a kind of are comprised by benthic foraminiferas, and these are oozes, where fusulinate limestone belongs to the Permo-Carboniferous age of the Paleozoic Eon, and the nummulitic limestones belong to the Eocene period of the Cenozoic Eon. Which kingdom do they belong to? Uh, these guys are generally single-celled organisms, and like amoeba, therefore they belong to the kingdom Protista. But what makes them different from other protists is that they have an anastomosing pseudopodia that is thread-like, and it's called the granular reticulopoda. Um, this kind of structure you can see here, and this is called the granular reticulopoda, and it has got a thick shell that is either composed of uh, other means particles like foreign particles cemented together, or either by mineralization that we'll see later. Uh, So some of the foraminiferas also do not consist of a shell or test, and these are very rare in number, and they're mostly freshwater specimens, and that also is observant from kind of molecular studies. There are now recent proof of that. And if you see the size, they mostly range from 0.1 to 1.0 millimeters, with very rare forms with up to 10 centimeters in size. Now, tests are generally, if they are non-mineralized, they're formed by cementing of foreign material, and if they are mineralized, they're mostly carbonates. That is, they have a group of CO32 minus, and rarely they are formed of silicates. So that's till here. Stay tuned for the next video to come. We'll discuss further more on this thing. So stay tuned.